Hello students, today I am going to discuss coordinate geometry. In this section, first we derive relation between Cartesian and polar coordinates. If we consider a initial line OX and OY, two perpendicular lines, O is fixed point and OX is initial line. In that system, we can consider a point P with coordinate r, theta with respect to polar coordinate system, and in this point also can be represented by x, y in Cartesian coordinate system. For Cartesian coordinate system, we consider x, o, x dash and y, o, y dash to perpendicular axis. O is origin, and in polar coordinate system, OX as initial line, O as fixed point. So, if P is the coordinate of a point with coordinate r, theta, then we have distance OP equals to r and angle XOP equals to theta. And for Cartesian coordinate system, if we draw perpendicular line from P on x-axis, if PQ with the perpendicular distance, that is, if PQ with the perpendicular on OX, then OQ equals to X and OP equals to Y. Now, in triangle POQ, we can write, if this is theta, we can write tan theta equals to PQ upon OP. That is Y upon X, and PQ by OP equals to sin theta. This implies Y upon R equals to sin theta. This implies Y equals to R sin theta. Again, OQ upon OP equals to cos theta. As we know, base by hypotenuse equals to cos theta. This implies x upon r equals to cos theta. So this implies x equals to r cos theta. Thus we have, if P r, theta be the polar coordinate of a point and that of Cartesian coordinate be x comma y, then their relation is x equals to r cos theta and y equals to r sin theta. We have to remember this important relation. Using this relation, we can change any polar coordinate to Cartesian and any Cartesian coordinate to polar. For example, if 1, 1 be the Cartesian coordinate of a point, then its polar coordinate is as follows. Here 1, 1 is this. This is 1 and this is also 1. Using this, so this is origin and this is initial line. We have to find if P be the coordinate of 1, 1, then we have to find the distance OP and angle POX. Here 1 equals to r cos theta. Here 1 equals to r cos theta, also 1 equals to r sin theta. Therefore, r square cos square theta plus sin square theta equals to 1 square plus 1 square equals to 2. This implies r equals to root 2. And hence, tan theta equals to y by x equals to 1 by 1 equals to tan 45 degree. This implies theta equals to 45 degree. Thus, required polar coordinate is root 2, pi by 4. We considered another example of Cartesian coordinate to change its polar coordinate. Let us consider a point on axis. Let its coordinate be 1, 0. Then its polar coordinate is 1, 0. As distance from origin is 1 and this line makes an angle 0 degree with its initial line OX. So, any point on the x-axis is of the form, so any point on the x-axis is of the form a, 0 where a greater than 0, its polar coordinate is a comma 0. Now we consider a point is of the form 0, a in Cartesian system. Then its polar coordinate is a comma pi by 2. Since here a point with coordinate 0, a lies on y-axis, and this makes an angle pi by 2 with the positive direction of x-axis, and its distance from origin is obviously a unit. So its polar coordinate is a comma pi by 2. Now we consider another coordinate is of the form minus a comma 0, where a greater than 0. That is, this point lies on negative direction on x-axis. Negative direction on x-axis. If this is the coordinate of a comma 0 and this is x, this is y, this makes an angle phi with the positive direction of x-axis, initial line, and this distance from O is a unit, and hence its polar coordinate is a comma pi. Similarly, if we consider a point with coordinate 0, minus a, where a greater than 0, then its polar coordinate is a comma 3 pi by 2, as this is original line, y initial line, and this is the point minus a comma 0, and this makes an angle 3 pi by 2 with the positive direction of x-axis, and hence its polar coordinate is a comma 3 pi by 2. So student, we can find any kind of Cartesian coordinate corresponding to polar coordinates and polar coordinate change to Cartesian coordinate using above formulas. That's all. Thank you. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.